Hi everyone, welcome back to Art of the Part. In this video, we're going to start looking at our fidget spinner case study. So you can see here, I have a SolidWorks assembly open with our 3-spoke spinner sitting on top of a soft riser that we need to make for work holding so that we can use this on the mill. So if we're looking at this from a manufacturing standpoint, we have to consider that we have a circular component that needs to either be held or bolted down to a flat face on the table or sit between two square jaws. Now I know that we can use a chuck or a circular chuck for the mill, but not everyone has a chuck dedicated for their mill. So I want to approach this from more of the simplest terms possible. So that said, we are going to get into this. I'm just showing you where we're going, but I do want to approach this video from a more introductory standpoint as well as a design and hierarchy approach. So the way that I would design this 3-spoke spinner here is I would probably start it off by doing a revolve or a boss extrusion from a diameter, and then start drawing my sketches for these specific pockets and do a cut extrude, some edge breaks, sweep cuts, fillets, so on and so forth. Now, let's say my 3-spoke spinner is wildly successful and I want to go ahead and start moving into a 5-spoke spinner or a 7-spoke spinner or a 10-spoke spinner. Now, do you think that I, as the designer, want to go through the process of setting up that revolve and that boss extrusion every single time? Probably not. It's pretty tedious, and there's a lot of chance for human error, especially when you're trying to match a previous file or trying to make something uniform. So we talked a little bit about this in previous videos, especially with the work holding assemblies and using a singular blank. And what we want to do with this file, in my opinion, is to actually make a singular blank that we'll pull from. So we could easily make this on like a mill or a lathe, and my preference would probably be to turn it and make it turned blank. And then go ahead and take this turned blank and then put it on a mill and attach it with the work holding, and then go ahead and mill out the shapes of the pockets afterwards. So there's a lot of advantages for creating those parent-child relationships, because if I have to make a change, for example, maybe the bearing that I'm using for this turned part gets changed, and I have to go ahead and update it with the ID. So do I want to go through my 3-spoke, my 5-spoke, my 7-spoke, and my 10-spoke, or do I just want to go ahead and update this one file? So I think this also lends itself to the different machines that we're going to be going into as well. So I mentioned that I would probably turn this on a lathe, and if I want to make a lathe turning program, I have to have a file for it, because I don't want to try to access my milled file and then recreate geometry from it and then try to get my turned geometry from the milled file. So if I have a insert part blank, which is going to be our parent, well, I can associate all the turning geometry to this one blank. And then as I go and insert it into a new design file, I can go ahead and mill out the 3-spoke, or I can do another file for a 5-spoke or a 7-spoke or a 10-spoke. So those are just some things that we should keep in mind as we go through the design hierarchy approach. So as we draw this part, I'm going to start off with the insert blank, or the fidget spinner blank, and I have a drawing for us to reference. So you can see here, I have this circular disc, and we have a 3-inch diameter, and then we have this locating pin so that we can flip it from one side to the other, as well as this center bore geometry that we need to consider. So one thing that I want to make sure of when we start off this part is that we're drawing it in the right plane or orientation. And if we look at the final model, we're considering with the final model that the geometry from one side of the fidget spinner is the same to the other side. The only difference where there's no symmetry is going to be with this center bore detail. So I have to keep that in mind when I'm drawing this blank. And I'm going to try to consider that the center, or the heart of this part, is just right here in the middle of the center bore. So all the geometry to the left and to the right are going to be mirrored over. So let's just keep that in mind as we start this new SolidWorks part. So I'm going to go ahead and close out of this assembly, and I'm going to go ahead and file new. And you might see a screen that looks like this. Go ahead and start a new part. I'm going to use a template that I previously set up, so all of my design criteria, like my dimensions as well as my background, are already preset. So I'm going to look at this part and think how I'm going to manufacture it. So again, I said that I was probably going to put it on a lathe and turn it. So if I was in a turning or a lathe operation, I would try to draw this on the right plane. However, I'm going to kind of favor the mill in this video just because we're doing most of the work in the mill. And I'm going to try to make sure that whenever I do my insert part, that it's in the right orientation to go into the mill. So right now I want this part to sit not on the right plane, but I want it to sit on the top plane so that when I pull it into the mill, it's always going to be orientated to my work holding. So when we're looking at the top plane, we have to consider that it needs to be revolving around another plane, which is going to be actually our front plane. So it's revolving through the front plane around it, and it's going to create that top surface. So let's go ahead and start a sketch here on the top plane. And what I'm going to do is I'm going to actually create 2 reference lines so that I can use one for the axis when I revolve my part, as well as one for a reference to mirror my part. So inside of this front plane, we're going to go and into the sketch tab, and we're going to find our line tool. So it's in the top left here. I'm going to hit the drop down menu of the line tool, and I'm going to find center line. And using the center line tool, I'm going to draw one line off the origin going up, and then another line off the origin going right. So before you draw these lines, make sure that you're getting a origin or a center coincidence here. You can see that as the little orange dot, and I'm going to click and lock myself to the origin. And then when you're drawing your lines up and to the right, make sure that you're also seeing a vertical relationship when we're going up and Y for the vertical. And then if I hit escape, because it's going to continue to draw lines, because I don't want to draw another line over like that, I want it to come off the origin. I can also come back here into my sketch tool and hit the drop down and find the center line again, or I can just hit the enter button on my keyboard, and it's going to pull up the last command that I did. So I'm going to get that center line off my mouse again, and I'm going to click on the origin. And once again, we want to make sure that we're seeing that horizontal relationship. And this is going to the right in X. So I'm going to drop that somewhere over there and then hit escape on my keyboard once again. So now I have my 2 reference lines. This line in Y is going to be our center axis when we revolve, and this line in X is going to be the mirror reference line that we're going to use. So we're going to hop back over here to the sketch tab, and we're going to use the line tool once again. We can either hit the line option right off the bat, or we can hit the drop down and get the line feature. And what I want to do is I actually want to try to link my line to the endpoints of these reference construction lines that I just drew. Now, be very careful, because if we look at this part, we see that we have a center bore going through the middle of it. And to include this center bore, we cannot have a piece of geometry built off of this line in such a way that the part is solid. We actually want that revolve to include that center bore detail. And I'll show you a bad example of what happens when you go off the center line in a couple steps here. However, I want to start you off on the right foot. So I want to actually pull like a snap dimension and leave some space off of this line in Y. So I'm going to try to move my mouse so that's in line with the endpoint of that line. And then I'm going to click once somewhere over here. Again, not on this line, but somewhere over here. So I'm going to click once here. And I'm going to draw a line over to the right. And I'm going to try to get this to wake up the endpoint of my horizontal line that I drew in X. So I'm going to see that snap again. I'll click once again, and I'll click down here and connect it to the line that I drew horizontally in X. And I'm done with the lines tool right now. I'm going to go ahead and hit the escape button. So make sure that you're at this point, and I'm going to show you a bad example, so don't follow it and end up ruining your part. So if I was going to go ahead and revolve this, I would actually see some geometry if I completed the center bore. However, if I pulled this off of the center line itself, and for example, if I drew another line like that, and I did a revolve, if you see this in a couple steps, this is why. Because you didn't give enough space off the center line where the part is solid, and we lost all the geometry for the center bore. So I'm going to go ahead and hit X, and I'm going to undo and undo. So I get back to this stage here, and I'll go normal too. So we can always like reposition these lines to where we want them to be. It doesn't really matter where they end up in X and Y right now. We're going to smart dimension it here. But if you want to get it close to this shape, it might help you out. However, I'm going to go ahead and use my smart dimension tool. So if you go over here to Sketch, and inside Sketch, we're going to locate smart dimension. You have to imagine that we're looking at the part as a half, and we're revolving around the center. So right now we're just looking at a portion of the pie, or like the radius of the diameter. So if I click on this line here and then I click on the center line, that dimension is going to truly be a radius dimension. However, if I want the full 3-inch diameter, which is going to be right here, see how we see the diameter symbol and then 3 inches? If I want to see that full value without having to do the math and divide everything by 2, well, as long as I have a center line in place, I can take my smart dimension and pull it over the center line, and that's going to give me the full diameter dimension. So you see how it's doing that? And make sure when you're doing this step here that you aren't grabbing a point, because the point to the line might not, well, it actually worked out in that instance. It's lucky. So you can either do it from a point or a line. I've had some issues before where it's going from point to line. So I'll grab that. I'll just repeat this step here. Grab that line, and then we'll hop over the center of it so we get the full diameter. And I'll type in 3-inch for the diameter. Okay. And the same thing, if we look at the thickness of the part, we see that there's a 281 value. So I'm going to go ahead and click on this top edge, click on this edge, and again, you can see either half the dimension or the full dimension. So in that full dimension, I'm going to type in 0.28125. Okay? And then I'm going to go ahead and move into a new function here, which is going to be mirror. So we've never used this before in class, and we're going to actually mirror this top half of the sketch over this line to the bottom half of the sketch. So inside the Sketch tab, we're going to go and find Mirror Entities. So we'll click on Mirror Entities. And Entities and Mirror, it's going to open up this little properties bar. We're going to choose the 2 solid lines that we just drew. And then to mirror about, we're going to choose the horizontal line that we drew in X. So we'll click on this, and it's going to go ahead and mirror that over. We'll hit the green check mark. And you can see these 2 lines, or these 2 endpoints, are now going to be linked to each other, as well as the thickness of the part. So that mirror command really helps us out, especially if we have a lot of complex geometry that we want to be symmetrical on both sides. This is a pretty simple part. It's just flat from one side to the other. So you could have drawn the square or like this portion of the rectangle, and you would have been totally fine. However, I just want to show you some more new commands as we go through these exercises. All right, so now I'm going to start looking at the centerboard detail. And if we go over here to the drawing, I actually have the solid part, and then I have a cross section of the part, and then I have a detail view of the centerboard. Because there's quite a few steps that we have to consider as we look at the centerboard when we put the bearing and then the 2 thumb screws onto it. So what I'm going to do is I'm going to try to memorize the number of steps here, and I'm going to try to freehand this. So I'm going to go down, over, down, and then we're going to try to create this little valley here. So I'm going to minimize this, and I'm going to try to memorize those steps. So we'll click on the line tool once again, and we'll go to the endpoint. And this is very important, especially with the centerboard detail, that you do see vertical and then horizontal relationships as you're clicking through these lines. So that first step, we're going to go down. We're not really going to care about the dimensions yet. We'll come back and smart dimension everything here at the end. So we'll come down once in vertical, and then we'll come across once in horizontal, and then we'll come down again in the vertical. So we did down, over, down, and then I believe there's one more step I'm going to go ahead and check. So we did down, over, down, and now we're going to go over once again and then down and make that last down in line with the bottom of the face. So we're going to come over and then down in line with the face, and then we'll come across, and we just have to create the little valley that I was talking about. Make sure we're not accidentally, and I accidentally just did it there, where this is going to be linked to that line. Make sure that you leave it a little before or a little after this line so that it accidentally doesn't snap to it. So I'm going to click over, and then we'll just make this in line with that. And I can see that this line is not in line with that. So if I wanted to apply a relationship after the fact that snap didn't work, I can always click on a line, hold down the control key, and then click on another line. And while still holding down the control key, I get access to my properties here, and I'll make that collinear. So this is the detail that we have for that center bore. I'm going to go ahead and smart dimension this out. So this is where that center line is really going to be advantageous for us, because I really do not want to do the math on some of these fractions. So what's half of 0.875 and what's half of 0.498? So I want to utilize that center line that we drew to get the full diameter dimension. So this dimension here, from this edge to that line, I'm going to go over the center. So I'm not getting the radius, I'm getting the full diameter. I'm going to make that 0.875. Okay, and then this diameter here, from here to that center line, it's already picking it up. That value is going to be 0.498. Okay, so I'm going to type in 0.498. And then this step here is going to be the 0.438 through. So we'll click on that line. And it's already remembering from that center line there, and I'll make that 0.437. Let's start positioning some of these. You can see how that actually pulled over. I can actually escape, just reposition that and get back into my smart dimension. Okay, and then this step here was going to be 0.625. And then we can get all the heights of everything here in just a second. So again, grabbing the line there, grabbing the center line, and then coming across the center line, and I'm going to give a value there of 0.625. Okay, so we've got all of our diameters, and now we're going to start looking at the steps. So I'll come back here into my drawing. First step there is going to be 0.078. It's going to be mirrored on both sides, and then the center of it is going to be about 0.125 in thickness. So if I wanted to, I could go ahead and grab this top edge, this line there, and then the full fractional value of that is going to be 0.078125. Same thing for this one, 0.078125. And then this step here is going to be 0.125. Okay? So that should be fully defined. We want to make sure that we see fully defined down here in the bottom right. And we will be able to now revolve it around without any hanging geometry. So I'm going to jump over here to the Features tab, and inside Features, I'm going to utilize the Revolve Boss Base. So we've always used the Extrude Boss Base before, so now we're going to use the Revolve Boss Base. And it's going to be asking us for an axis of revolution. So just like how the mirror function before was asking us for an entity to mirror around, we want to have an entity to revolve around. So that axis of revolution right there, we'll click on that blue box. We're going to select that line that we drew in Y, which is going to be vertical. So you can see when this is fully dimensioned and fully defined, and we aren't touching the center line, we actually see that center bore geometry. So we see a hole through the center of the part. And we'll hit a green check mark. So that is pretty much the blank, with the exception of one detail, and that's going to be the locating pin. So I'm going to go ahead and draw a sketch here on the top base, and we're just going to draw this locating pin so that we can locate the part no matter what spoke that we're using. So one thing that we want with that locating pin is for that hole to line up either with a 3-spoke or for a 5-spoke, so we can use the same work holding geometry, because that locating pin is going to be tangent to that hole that we put in this operation. So whatever design that we're doing, just make sure that we have an area where they're going to overlap, and we can see that tangency through that locating pin. All right, so that locating pin is going to be a 250 hole, and then it's going to be through, and it's going to be on a bolt circle of 2 inches. So we'll start a sketch here on this top base. We'll get the circle tool, and we'll just go off the center of the part, or the origin. We'll draw a circle out. We'll hit escape. We'll click on this, because when we go to do like extrude cut, we don't want this value to actually extrude with it, so it has to be construction geometry. So you see how it was solid blue that's considering it as complete geometry that will cut through? Construction geometry is ignored, so we just want the bolt circle dimension from that. So I can smart dimension that, and I can dimension it at 2. And then I can get a circle tool again, and then I'll get one of these quadrants. And I'm going to use the 12 o'clock position as my quadrant here. And then I'm going to draw another circle out, and I'm going to smart dimension that at a value of 0.25. And then this is just easy peasy, features, extrude cut, through all. So again, we just finished the part. Let me propose this and say, okay, we spent about 5 to 10 minutes drawing this part. Do you want to do that every single time that we switch from a 3-spoke spinner to a 5-spoke spinner to a 7-spoke, 10, so on and so forth? Or do you just want to continue to pull from this one parent file? So all these other design files that we're going to move into next are going to be our children file. So I think that this is a better approach, especially when I save this out. I can attach all of my turning operations to this one file, and I can attach all of my milling operations and programs to my design files. So let's go ahead and save this and end the lesson. So I'll go File, Save As, and then I'm going to name this the Fidget Spinner Blank. And I'll just put 1 after it, and I'll save that. So in the next video, we'll actually insert this into our design file, and we'll draw the 3-spoke spinner, which is going to look like this. So thanks for watching, and I'll see you in the next one.